In the Beginning by Dr. Walt Brown. Meandering River Beds, Meandering Rivers, page 242. You can look at this on a flipbook at hpt.rsr.org or creationsciencecenter.com or somewhere in there. Okay, meandering rivers. Several rivers meander dramatically within the basins of the former Grand and Hopi Lakes. Gooseneck State Park along the San Juan River contains the Western Hemisphere's most extreme segment of a meandering river or stream. Why do rivers meander? And what conditions produce such extreme and deep meandering in a river that is why do rivers meander, and what conditions produce such extreme and deep meandering in a river that today is so small and sluggish? A river flows faster on the outside of a bend than on the inside, just as the outside of a merry-go-round travels faster than the inside. The centrifugal force pushing outward then raises the water level on the outside of a bend. Therefore, the river's surface water flows toward the outside of the bend, and the bottom water completes the circulation by flowing towards the inside. So, river flows in a corkscrew spiral pattern around a bend. Sediments eroded by the faster flow along the outer bank are transported to and deposited near the inner bank, where the flow is slower and less able to carry sediments. Even on rivers that are initially fairly straight, slight curves expand and meander increases if the flow is fast, high, and steady. Meander occurs on broad, flat floodplains. Deep meanders, as seen in figure 139, require a large floodplain with deep, loose sediments. Figure 139, that must be this one. Yes, it is. What does it say? Goosenecks, one of the most famous meandering rivers or streams. Goosenecks, one of the most famous meandering rivers or streams is the San Juan River, which flows entirely within the basin of the former Grand Lake. Here, near the town of Mexican Hat, Utah, is a section of the river called Goosenecks, where the river has cut down through 1,000 feet of sediments and meanders 5 miles over a distance of only 1 straight mile. Similar meandering extends 11 miles upstream and 11 miles downstream from this location. Is there a reason for such extreme meandering in Grand Lakes Basin? Okay. Where was that? Okay, figure 139. Meanders occur on the broad flat floodplains. Deep meanders, as seen on figure, require a large floodplain with deep, loose sediments. The flow out of Grand Lake encountered a major bottleneck slightly downstream from what is now the Gooseneck region, so the flow slowed and dropped its sediments. After the bottleneck cleared, the flow was rapid, so sediments were scoured and the channel deepened. After the lake emptied, subsurface water steadily drained into the San Juan Basin all along its 1,000-mile-plus perimeter, making the San Juan a powerful river for centuries, especially along the steep channel eroded down. After the lake emptied, subsurface water steadily drained into the San Juan Basin all along its 1,000-mile-plus perimeter, making the San Juan a powerful river for centuries, especially along the steep channel eroded down through the bottleneck and slightly beyond. This steepness, slight headward erosion back through the still loose sediments, and the high volume of water provided the considerable energy needed to excavate the meandering river's outer banks to the extent seen today. Why did the goosenecks develop such uniform and symmetrical meanders? Today, rivers are fed mainly by surface flow, so their depths, sediment loads, and volume flows rates are seasonal. This produces varying meandering patterns. However, the early San Juan was fed largely by subsurface water, steadily draining during all seasons into the vast San Juan basin. So centuries of fast, steady flow conditions produced uniform, symmetrical, meandering patterns. Let's take a look at that. Goosenecks right there on the San Juan River. Fascinating. Okay, and where were we? 242 or somewhere about. Yeah, that's where we were. Okay, that's Meandering Rivers from In the Beginning by Dr. Walt Brown. Again, the flip book's available at hpt.rsr.org.